Well. It's Mr. Thompson here with a video science lesson. I'm still so used to saying video math lesson. Anyway, here we are. I'm going to do some worked examples. Going to show you, take some problems with speed, displacement, and velocity and show you how to do them. Okay? So the first example that we're going to do is a speed example. Okay? So this problem says calculate the average speed of a, we'll see if we can switch me, there we go. Calculate the average speed of an airplane that travels 2,730 kilometers in 3 hours. Okay, so the way we do this is using our formula for speed equals distance over time. Okay, and so we do the distance, 2,730 divided by 3. The distance over the time, 3 hours, 2,730 kilometers, the distance over the 3 hours. So when you divide that, plug that into your calculator or whatever you want to do, you get 910. Now what are the units? Okay, it was kilometers divided by hours, so that means it's kilometers per hour. It's just literally exactly what you did, kilometers divided by hours. Okay, now what if the problem says answer in meters per second? Well, if you remember, it's actually in the acceleration video, a little bit backwards, but to convert from kilometers per hour to meters per second, we divide by 3.6. Okay, so we're going to take our 910 and divide by 3.6, and we get 252.7 repeating, which we will round to 252.8, and we can make that meters per second. Okay. That one, there's one problem done. Okay, we're going to do some more, meters per second. We're going to do some more speed problems because there's a few different ways that they can look. So here's a problem. It's not asking for the speed. It's giving you the speed. It says, how long would it take a lion to run 6 kilometers? And I can put my video back over the other side. How long would it take the lion to run 6 kilometers if it can run at a speed of 30 kilometers per hour? Okay, so it gives you the speed, gives you a distance, asking for time. So again, from previous videos, I explained these equations, and we know that time is distance over speed. If we do distance divided by speed, we get the time. So we take the distance, 6, divided by the speed, 30, and of course we can simplify that to 1/5, or we can make it 0.2, and that would be, we were doing kilometers per hour divided by kilometers. What happens is the kilometers actually cancel. It's like kilometers divided by kilometers. Those just go away. And it's like kilometers over kilometers per hour, and that hour ends up flipping around to the top. And so it ends up as hours. It's 0.2 hours. That's a perfectly acceptable answer. But we could also say that's 12 minutes, 1/5 of an hour, 12 minutes. Okay. Next problem, example 3. How far would a bike go in 3 minutes at a speed of 5 meters per second? Okay, this time we're going to use the third version of this equation, where it's distance equals time times speed, or speed times time, right? So we just take our two numbers. It's at 3 minutes. Oh, we don't want to just take our two numbers, because what we do, we look at this and we see that we've got different units. We've got minutes, and then we've got meters per second, right? So minutes and seconds. We need to harmonize that, make sure we're using all consistent units. So the easiest thing to do is to switch the 3 minutes into seconds. So 3 times 60 is 180, so it's 180 seconds. So we're going to do 5, the speed, times 180 for the time, which is 900, and it was meters per second times seconds. The seconds cancel, and you just get 900 meters. Okay. All right, that was speed. If I went too fast, just back up and watch it again, or pause it or something. We're moving on to displacement. So our first problem in displacement says calculate the distance and displacement from A along the path to the other point. So we've got this rectangle, okay, and we're going to start at A, then it goes up to B, then goes to C, then to D, and then back to A. So we want to calculate the distance and the displacement along at each point along that path. Okay, so from A to B, it's pretty easy. It's a straight line. So with a straight line, the distance equals the displacement. So we've got distance. We're going to do distance and displacement. Of course, it's a distance of 8 along there. So the distance is 8, and like I said, the displacement's the same. So that's 8. Now, from A to C, right, we go up along the path and then over that way. Okay, so the distance is easy. We just add 8 plus 15, so 23. But the displacement actually goes along that line right there, right? That dotted green line, the diagonal. Okay, the displacement is the straight distance from start to finish. So from A to C, we have to use Pythagoras. We need to find that hypotenuse distance. So 8 squared plus 15 squared equals C squared. 8 squared is 64, and 15 squared is 225. So we add those together, that's 289. We're going to take the square root of both sides, and C equals 17. So the displacement from A to C is 17. Okay, the rest of this is pretty easy because it's all straight, nice straight lines. From A to D, we add the distance, so 8 plus 15 plus 8, so that's 31 meters. Okay, and the displacement is just straight along from A to D, which is 15. Okay, finally, from A all the way around back to A again. Okay, the distance, we add another 15, so we get 46 meters, the whole round trip around the box, rectangle, whatever. But from A to A, there is 0 displacement, 0 meters from start to finish, okay, because you end up where you started. Okay, that's how displacement works. Okay, moving on to everyone's favorite, velocity. And of course, if you understand speed, and you understand displacement, then velocity just slots right in. It's exactly the same. So we just have to consider the overall distance for the velocity. Okay, so here we have a dog, runs 300 meters west, then 200 meters east, and then 500 meters west again. So he's kind of running back and forth. First we have to, all of this takes, 2 minutes? Yep. Okay. We need to calculate the dog's part A, total distance. Okay, so total distance is 300, then 200, then 500. We add all those together, and that, of course, equals 1,000. So a nice, handy, clean kilometer or kilometer. I know I always go back and forth between those. Okay, part B, total displacement. Okay, so this is the overall from start to finish. Now, it may help to draw a picture. Okay, I'm not going to draw a picture. It's just one direction and then the other direction and then back again. But if you are a visual type person, then I recommend drawing a picture. But ultimately, as we have underlined here in blue, the west, he goes a total of 800 west. Okay, so total of 800 west and a total of 200 east. Okay, so he goes more west, or he or she goes mostly west, but a little bit east. So what we can do is take the total west and subtract the eastward direction, and it's a total change of 600. Okay, that's the total displacement. All right, and we need to add the direction. So he mostly went west, so the direction he's going to end up is west. Right, now part C, average, because we haven't even gotten to velocity yet. It's coming. Part C, average speed. Okay, so that for that we take the total distance, which is 1,000, and we divide by the time, which we've got 2 minutes. Now, we don't want meters per minute. That's a bit silly. We want meters per second. So the seconds is 2 times 60, so which is, of course, 120, and 1,000 divided by 120 is 8.3 repeating, or 8 1/3, or we can just round it to 8.3. Okay, and that would be meters per second. All right, average velocity. Okay, so this takes the displacement this time, and we divide by the time. So the displacement is 600. So 600 divided by, again, 120, the number of seconds, which comes out to a nice, clean 5 meters per second. Okay, there's some speed, displacement, and velocity examples. I will be working on some example problems with acceleration and then some example problems of all kinds of other stuff with physics. So I'll talk to you then.